Okie dokie. For now, number 2, CSEC AdMath May 2023 Paper 2 exam solutions. All right. So this one gives us this quadratic function and wants us to write it in the form. That's a vertex form. So basically, I want us to complete the square. All right. So let's do that. So I'm going to start with the same f of x. I'm going to factorize away the 3 from these two terms. I'm just going to start right away. So f of x then will be 3 into, factorize these two terms only, x squared minus 3x close bracket plus 2 out plus 1 out here. I'm going to complete the square of these two values equals 3 into x. Half of this goes here, which is 3 over 2. Don't forget the square and subtract the square of this value out here. That's 9 over 4. What did we do? Close back the bracket, plus back this one. What did we do? We took half of this here and we subtract the square of that there. That's the process of completing the square. Those are your steps. Nice and easy. Then we're going to expand again with this 3. So 3 times this bracketed term first gives us 3 into x minus 3 over 2 squared. 3 times this expression gives me minus 27 over 4, as the 3 times 9 is 27. I'm going to add back this 1, but I'm going to add it as 4 over 4. 4 over 4, such that it will have the same denominator as this one. So I run out of space. And let me just make this a little bit smaller and zoom in. Make it smaller and zoom in. And then I'm going to add these, which is essentially 4 minus 27 is negative 23. So it's 3 into x minus 3 over 2 squared and minus 23 over 4. And that is it. I've written it in that form, which is a vertex form. Question says, see the coordinates of the minimum point. And minimum point will be where this expression is 0, and that is your y value at the minimum point. All right, so they said to state it, it's where this expression equals 0, and so it's where x equals that. So because for this to be equal to 0, the x has to be equal to that. So my minimum point will simply have, I'm just going to state it, coordinates 3 over 2 from this value, and this is going to be my y value at that minimum point, negative 23 over 4. That's my minimum point. Nice and easy. Next part says, this equation has these rules. Is it the same equation? Is it? No, it's different function. Okay, different question altogether. So this equation has these two rules, alpha and beta, and they want us to find this. So this is a sum and product of roots equation, sum and product of roots of a quadratic equation. All right, multiple ways to do this, right? Firstly, I can say that the sum of the roots, which is alpha plus beta, is minus b over a. Minus b over a. The b is this negative 6, so it becomes minus negative 6 over the a. The a is 3, so I'm going to put that 3. That becomes a positive 6 over 3, which then is a 2. And then the product of the roots, which is alpha beta, is equal to c over a. And the c is this negative 2 over this 3 over 3. That's my alpha plus beta and my alpha beta. I'm going to need them because I want to write this expression. We don't give a lot of space. So let me put these side by side. Let me put these side by side since we don't have a lot of space to work with. All right. Put these side by side. I wrote this part in purple. So now I'm trying to find this. All right. It's going to be expressed in terms of the alpha plus beta and the alpha beta. So you now know those values. So the 1 over alpha, 1 over alpha plus the 1 over beta. When I make it the one fraction by multiplying this one by beta over beta and multiply this one by alpha over alpha, I get on the numerator, remember, this one, I'm going to multiply this one by beta over beta, multiply this one by alpha over alpha. So the denominator is alpha beta. So I'm going to put alpha beta as my denominator. The numerator becomes alpha plus beta. So it's pretty standard, alpha plus beta. So the result becomes the sum of the roots, which is this 2, divided by the product of the roots, which is this negative 2/3. Negative 2/3. So to divide by negative 2/3 is to invert and multiply. So it becomes 2 times minus 3 over 2. Invert and multiply. Or I could say this denominator comes to the top. Let's do that. Do the mathematics the easy way. So I can just write this as 2 times 3 over negative 2. So it becomes a negative 3. So my answer here is negative 3. All right, because this will cancel this. So my answer there is negative 3. Negative 3. Done. Next part. This part says John's grandparents started a university fund for him at a bank with $4,000. So that's an initial investment of $4,000. The bank offered 2 options. Option 1 is this option, 2 options for interest. Okay, options for interest. So the interest in option 1 is $240 per year. The second one is to do a 5%, an interest of 5% on the current balance. Okay. So in this case, we're adding $240 every year. In this case, we are adding an interest of 5%. So it means that this means we are multiplying by the new value is going to be 105%. So the new value is 105%. Let's make a note. So it's 105%. That's the new value. And 105% is equivalent to 1.05. All right. So we're doing this multiplied by that amount every year. This is my interest rate, 1.05. My interest rate is 5%, but my new value is going to be 1.05 of the original value. It says determine the sum of money in the university fund at the beginning of the 9th year. So if we are going to the beginning of the 9th year, it means that we have completed 8 years. All right, so this is very important. The beginning of 9 years means that we are at the end of 8 years. So it means that we would have applied the investment for 8 years. Okay, option 1 and 2. I want first to do it both ways. So option 1. Option 1. So in option 1, we are adding $240 every year. So remember, in year 0, when we started at the beginning, all right, and we're going for 8 years. So year 0, at the start, the amount would be $4,000. In year 1, we would add $240 one time, 4,000 plus $240 one time plus $240. And based on this, we'll be adding this $240, the same number of years that we have. And therefore, in year 8, which is what we're basically looking at, year 8, the amount is going to be $4,000 and we would have added this amount 8 times. 8 times $240. So this will give us the amount there in option 1. Is there enough space to work? Okay, yes. So we're gonna do this calculation. All right, so let us get the calculator. Let's get the calculator right here. Create a screen. So I'm doing 4,000 plus times plus 8 times $240. So I would have added $240 8 times. All right. So your zero is when we started, and we are doing investment 8 times to get to 8 years. So total in there in option 1 after 8 years is gonna be 5920. That's the answer for option 1. Then we're gonna go for option 2. So I can look at it. Option 2. So in option 2, year 0, we have the same amount of $4,000. The amount in there is $4,000, right? So this sum doesn't mean that we're summing the values. This sum really means we're looking at the amount, the total amount of money in the account. What happened is that this option 1, the value in the account is following an arithmetic progression, but we don't need to do it as an arithmetic progression with the formula for arithmetic progression. And in the second case, the value in the account is following a geometric progression, because you're going to be multiplying by this this ratio. That's going to be a ratio, the amount that you're multiplying each term by each year. But if we look at it in a simplified way, year 1 on option 2, not option 1, on the option 2, the year 1 amount, after year 1, the amount is going to be $4,000 times 1.05 one time. We're going to multiply it one time. If I just to do one more calculation just to show the pattern, year 2 is going to be this amount. I apply now the interest to this amount. So the new amount after year 2, or the total in the account after year 2, is going to be 4,000 times. I'm going to multiply this another time. So it's going to be 1.05 squared. And so that shows a pattern. Let me make this a little bit smaller. Shows a pattern. So we don't have to do it as a classic APGP question. This one can be reasoned out. All right, can be reasoned out. We don't have to go for the classic APGP methods for this one. Don't even need to use any formula. Simple reasoning. And so we're going on to year 8. So therefore, at year 8, the amount is going to be 4,000 times 1.05 to the power 8. That's going to be the amount in there. I mean, that would have multiplied this by 1.05 8 times. And so we're going to work out what that is right here. It's going to be 4,000 times 1.05 raised to the power 8. That's good. Raised to the power 8. Raised to the power 8. I messed up. My calculator is messed up. Hold on. 1.05 raised to the power of 8. All right, so I'm just going to give out the 2 decimal places and write 5909.82. So those are my 2 answers. This is my answer. This is my sum for option 1. That's my sum for option 2. That is it. Nice and easy. No need to go for the classic APGP formulation. Wow, this question is already done. Beautiful. I want to get through this as quickly as possible. So I'll do number 3 down here in the next video. So I'll stop and then go for